More good evening? Yeah. Okay, so good evening. My name is Daria Cegiełka. I study physics at London, but we stay in biology issues because I have chosen the topic about cell migration. But first, please let me tell you about my favorite cartoon from childhood. It was called Once Upon a Time Live, and it was full of amazing characters. One of it, a neuron, you can see here. Neuron was responsible for delivering information from our cells to our brain and vice versa. It was really, really fast one. Do we also have such fast neurons in our body? Of course no. Neurons are rather static characters, yeah? It is electric pulse, which is so fast. But, well, from the time I was a little girl watching that movie till now, it passed a lot of years and a lot of centimeters, because I'm not so small anymore. And the neuron which connects my toe with my brain had to grow up with me. And here you can see, now you can see the real neuron growing. You should watch it from that side here, okay? So it's some kind of migration, isn't it? Another great characters were these cells. While migrating, they were holding their hands, so they were migrating together, collectively, yeah? And in our body, we also have such cells. They are epithelial cells, for example, cells of our skin, which migrate until they touch their neighbor. And such mechanism, as you can see here, is responsible for wound healing, for example. But my favorite characters were these adorable macrophages. Macrophages are part of our immune system. They are responsible for protecting us from viruses and bacteria. And they are, truly great. I love them. But in real life, they are even better. Here you can see the macrophage, which is chasing the bacteria so as to phagocytize it. So that means that it would eat it and destroy. And that's the whole way of it. But I would like to draw your attention on one quite important thing. There are actually two bacteria here. Maybe on that picture you can see that. There are two. But macrophage is following only one of them constantly. It's quite remarkable because if macrophages will changes its its object of interest, the bacteria will be able to cheat it in groups, for example. Okay, so we saw neurons, we saw epithelial cells. Now we saw that macrophage which looks like an elephant, and now we are ready to saw really famous cross-section. I'm almost sure that you all know it, but I'm not so sure if you know that such cross-section is really similar to cross-section of real cells. And the general mechanism of migration of real cells is also similar to the mechanism of migration, let's say imaginative mechanism of migration of such snake. So let's precise. The snake is the microtubule cytoskeleton of the cell, while elephant is the heavy nucleus of the cell. How should such elephant with a snake migrate? First, the situation is symmetric, and symmetric needs turn off the sound a little bit because I need to show it. First, it's symmetric, yeah? Then symmetry breaks. And it's elongated from one side, attached to the surface, contracts a little bit, and release. By replicating such move, it is able to migrate, yeah? But it could be different when it comes to different environments. In that transparency, you are able to see that migration I was talking about is in 2D. Here, in 2D, a cell is migrating like that and is occupying the space, really great amount of space. While in 3D and 1D, migration pattern is different. Cell is more like a balloon. How a balloon could migrate? Let's imagine balloon, yeah? We have a balloon, how it should migrate. it has to shrink in one side so as to explore the other side, yeah? And that would be the migration pattern of the balloon, yeah? And that's also the migration pattern in 3D extracellular matrix and in 1D in fibrillar lines. In 2009, Doyle and Wong made a research about influence of dimensionality of environment on cell migration. And what they found could be seen on that picture. First, they made some qualitative analysis, and they noticed that in 1D and 3D, migration is quite similar because it's uniaxial. It's all about one line, yeah? In fibrillar line and in extracellular matrix, we go through one line, which you can see on that transparency. But they also made some quantitative research, and they measured velocity of such cells. And what they found is that velocity in 1D and 3D, on that graph here, is similar to each other, in contrast to velocity in 2D, which is way smaller. That star above means that the result is significant statistically. Okay, that was the research. And interestingly enough, they also measure what is happening when cell is changing the environment of moving. And that's what you can see here. Cell is going through one-dimensional environment to 2D dimensional environment. And what you can see is that cell is in real time changing its way of migration. It's going through balloon-like one in 1D to snail-like 2D, yeah? And it's occupying a lot of space. Okay, so to sum up that research, it's important that we notice two facts. First, environment alter cell migration. Its character changes because of the dimensionality of environment. And second one is that migration in 1D can mimic cell migration in 3D because of the velocity, which is similar, and because of the uniaxial character. And okay, we studied some part of our work. We know something more about cell migration, but is it really important or useful? The first thing which comes to my mind when I first saw it, it is medicine testing. How do we test our medicines now? We put it on a glass dish, which is 2D environment, in vitro, and we test it. Then we put it to the 3D system, which is our body. But as you could see, 2D migration and 3D migration is quite different. So that research suggests that if we try to make our research first on 1D environment, then it would be probably more efficient when we put it to the human body. But of course, it is the field for closer examination in future. That research is from 2009, and I'm not sure. I now still test medicines as we used to, so it's not proven well until now, but there are some features which can suggest. As you could see, migration, which seems quite simple, quite easy for us, could be really mysterious. And there are more mysterious features in cell migration. For example, cell migration, collective cell migration. You remember the cells which were holding their hands? We also have some research about cell migration, collective cell migration, where there is proof that there is one quite special cell which leads all of other cells in collective migration. Is called leader cells. And it's also not sure, we are not sure what is different in that cells, why this cell is so important in collective migration. I hope that I convinced you that cell migration is not only a colorful, cheerful, or quite mysterious issue, but if we study it well, it will appear that we use it on our everyday basis. Thank you.